Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With the launch of their managed Kubernetes platform, it's easy to get started with the next generation of deployment and scaling, powered by the battle-tested Linode platform, including simple pricing, node balancers, 40 gigabit networking, dedicated CPU and GPU instances, and worldwide data centers. Go to pythonpodcast.com/linode, that's Linode, today and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host as usual is Tobias Macey, and today I'm interviewing Leon Thomm about Ryven, a flow-based visual scripting environment for Python. So Leon, can you start by introducing yourself?
I'm Leon Thomm. I am from Germany, and I am a student currently studying computer science in Switzerland. I finished high school last year, so just started my bachelor. So there is still a long way to go for me, hopefully exciting way to go. Yeah, and I'm very happy to be here. Thank you for the invitation.
Absolutely. And do you remember how you first got introduced to Python?
Yes, I do. Actually, Python was the first programming language that I approached about 5 to 6 years ago, I guess. I was just doing some small high school projects with a few friends, and Python seemed like the perfect language. So Python introduced me to the world of programming. So I started with Python, and now for this project I'm going to talk about today, I kind of came back to Python, and I love Python. It's really great. The more I work with it, the more impressed I am about the design of the language and how well it works.
So you mentioned that Python was the first language that you started using. What are some of the other languages that you've experimented with since you first got started in the space?
Over the last couple of years, I tried to do as much different stuff as possible. So I did a lot of smaller projects using languages like Java, a little bit of web development with JavaScript, but mostly C++, because I don't know, for some reason I decided at some point I want to dig a little deeper into using C++ for mainly building desktop applications. So I got introduced into all this, the Qt framework. So this is where I learned the Qt framework in C++ for building large desktop applications. And this is what I used the most during the last years. From language perspective, I don't regret coming back to Python.
Yeah, that C++ experience, particularly with the Qt framework, is definitely useful with building at Ryven, because I know that that's at least the wrapper for the project. So I'm wondering if you can just give a bit more of an overview about what it is that you're building with Ryven and what your inspiration was and motivation was for creating it and spending your time on it.
Basically, Ryven is a small environment for flow-based visual scripting in Python. So what it is, it implements the idea of flow-based visual scripting using a more diagram-like representation to represent parts of your script, of your code. And it just provides with a software that makes it kind of intuitive. So basically, to give a little picture how this works, you have a scene and you can place blocks inside the scene, and you can connect these blocks with connections to define relations between these blocks. And this is how you define your program structure. Ryven is just a software that makes it easy to create these nodes and run these flows inside an application. And this is an idea, it's not so common, but I got introduced to it when as most people do, when I used Unreal Engine a few years ago for game development. And they are using this extensively, this paradigm of flow-based visual scripting. I worked with this for about half a year, and I really started to like it. And I was asking myself why this is not more common in more different areas. And I did a little bit of research, and I found a few other quite interesting systems, but I also found that it's not very common. So I was asking myself why this was so underrepresented in software. So I decided to start building my own editors, and Ryven is basically a very sort of Pythonic implementation of this whole idea.
You mentioned the overall paradigm of flow-based scripting and being able to build programs from these networks of individual building blocks. I'm wondering if you can talk through a bit of the overall use case or some of the particular problem domains where this approach is popular.
I think the best way is to give examples of the established implementations that some of them differ from Ryven, some are quite similar. So in Unreal Engine, for example, I mentioned Unreal Engine, and they have created such pretty big environments for using this paradigm for creating flows, using these flow-based diagrams to create code. And this does not just apply on code. So basically, you can define the game mechanics for a game that you're building with Unreal Engine just using these block structures by building these networks. They have a huge material editor where you have basically every node presents some kind of effect that you apply on an image or some kind of texture. It can be a plain texture, it can be a height map, and in the end, you just put everything together in a target node and it creates a full material out of that. That's a good example. Node-RED, for example. Node-RED is a software that is originally, I think it was developed by IBM. It's a browser-based, Node.js-based software for managing IoT connections. That was quite inspirational for the Ryven project. Shows also a very interesting use case, I think, because it's kind of like IFFT, but it's called IFTTT. It's a little bit like IFTTT, but if this, then that. So it's a little bit like this if this, then that thing, where you have a block that can be triggered, an event happens. For example, you receive an email somewhere or some file on your file system is changed, and then you can do lots of stuff up to writing a Twitter post or something like that. And it's very easy to use, and yet it provides an interface that where you can still program and add your own source code. So you have these function blocks where you basically can put JavaScript code inside it. And that's kind of the idea that I thought is very powerful and that I try to implement in Ryven. So with Ryven, it's really hard to explain to someone what the possible use cases of something like this would be, because there are just too many. And I feel like I'm not even qualified for listing the use cases, because it repeatedly happened in the past that someone came to me and said, hey, I'm using this for this and that, and wouldn't it be useful to optimize it in this or that way? And I was like, yeah, I didn't think about that application at all, but that's actually a great idea. So if I wanted to categorize it, pretty much anything that has to do with web APIs and workflow automation, stuff like that. Machine learning, it has very big potential for application with flow-based visual scripting, I guess. Things like that.
Yeah, I can definitely see a parallel to the machine learning space or the data processing space, because all of those frameworks structure the workflows as a directed acyclic graph. And a lot of them will provide some visual means of being able to view all the different nodes within that graph. And that's very analogous to the flow-based system, where you have these different building blocks and you can see the interconnects between them to see this output is going into the input of this other block, and then that's providing an output to another one. So you can have these fan-in or fan-out topologies, and you can see what are all of the structures that get you from point A to point B and the potential branching points. And so I can definitely see where that's useful in that arena, but I can also see a lot of other places where that would be valuable. You mentioned web APIs. You can see what is the actual network of the potential paths that you might take, where you have the root of the API for a particular object, and then you can see, okay, this branches into the specific instance of that object, and then that instance of that object has these other methods off of that. So it's definitely an interesting way to think about the way the program flows, rather than just trying to piece that together from looking at the textual information in your editor, for example.
Yeah, absolutely. One thing that's closely related to what you mentioned is also, I think there's a lot of potential for real-time. If you can implement some real-time access to your data, for example, if you have like a web API or you have some network system that is basically projected as a graph in your flow, and you have real-time data input, then this could be really useful for getting an overview of what's going on. So you have this static income of data, and you can just update the flow accordingly and basically create a small projection of your network or what your web API is doing. If you have that kind of real-time access to your data, I feel like this is something that hasn't really been done yet with flow-based visual scripting, but I see lots of potential for that.
That also is an interesting thing to dig into more is the way that information propagates throughout the program as you're interacting with the overall flow in the network diagram of your program logic. And I know that from digging through the documentation that you have a couple of different ways of allowing things to propagate depending on whether it's a data-oriented flow or a logic-oriented flow. So I'm wondering if you can talk through the trade-offs of those two different approaches and some of the ways that that helps you think about how to structure the program and the ways that the information flows throughout it.
The dualism that you were mentioning is the dualism between pure data flows and execution flows. And I think originally the first thing that was invented for first implementations of flow-based visual programming always focused on pure data flows, where you have basically one type of connection for nodes, and every connection basically represents you can think of it sort of as a pipe where you have a data flow through it. So from one node just passes data to another node, and this other node is notified when data comes in. But there's also a different idea that basically allows control structures, which is execution connections. So you have a different type of connection that is, for example, implemented in the blueprint editors. Inside the blueprint editor of Unreal Engine, most of the nodes are active, so they have these execution inputs and outputs. And these execution connections, they're basically like simpler data connections because they don't transmit any data, they just transmit signals. So they just trigger the activation of certain parts of your script or certain nodes and everything that comes afterwards. And there are two different approaches from an algorithmic point of view. So in Ryven, I wanted to enable both because both can be very useful. In general, the data flow approach is the more powerful one, but sometimes it makes more sense to introduce execution connections. So I wanted to enable both, and you can choose the algorithm that is used to execute the flow. So you basically say whether you are using a pure data flow or whether you have execution connections, and it uses a different algorithm. And basically, I'm not sure. It's hard to categorize it and to make a strict distinction for what you can do with the one approach and what you can't do, because I repeatedly saw people using the one approach that I would consider not the optimal one for doing the other thing. So it really works. You can totally build huge data flows that pretty much rely on execution connections. And you can definitely do anything that you can do with execution connections using pure data flows. It's a little bit different in the way the script is executed, but it's not a fundamental change, because what both have in common is a more logical thinking to the human mind. You have these blocks, and every block represents a certain procedure, whether this is just like one operation, like think of it as a variable assignment, or maybe there's like a big program written into this node. It doesn't matter. It represents one procedure. And when a signal comes in somewhere, whether this is data provided or whether this is just a trigger through an execution connection, this node is notified and updates itself, and then the procedure starts and it computes. I feel like this is a more human way of thinking as execution of a bigger script, that you have these step-by-step components and you just define. Using these flow diagrams, you define the flow of information through your program. And to me, usually kind of the more intuitive way to think of an application of a program. I think which is reasonable because these kinds of flow diagrams look a lot like mind maps or something like that. And there's a reason why those are called mind maps. So it's kind of a more intuitive way of thinking how data flows through your application. And I think that's also why, especially as you mentioned, for data processing, this has for sure huge potential.
And in terms of the Ryven project itself, I'm curious some of the things that you're using it to build for your own personal use cases.
One example would be during the semester, I had like linear algebra as you do when studying computer science. I had linear algebra last semester, and we learned all this like matrix operation stuff, right? So at some point, one of my student colleagues, approached me and asked me whether it would be possible to make this a little more intuitive using this diagram structure from my software by representing an operation on a matrix by a node. And I thought that is a really great idea. So I basically just took the functions and methods from NumPy and SciPy and put them into nodes, and which is a very quick process. And I just made a basic widget that displays the matrix inside the node. And I added this to all these nodes, so you can build your flow and build a chain of matrix operations, and you can change something at the beginning, and everything that's dependent on that updates immediately. This is a very playful way of finding similarities between matrix operations, and depending on what type of matrix you can use or you're using, you will find like symmetry somewhere. And this is really cool. Because this was also inspired by things like Node-RED, I also used this for smaller IoT-based stuff. I got this running, I don't know, about like 8 months ago or something on my Raspberry Pi. So the software on my Raspberry Pi, and I did some very rudimentary basic network connections to catch some events. If when some sensor is receiving something, I do this and that. And this is very intuitive using this kind of flow structure. Yeah, there's a lot that other people have done that I didn't even try. The hardest thing is to say for what this could be used, because it's not something that is specifically designed to be used for a specific domain. You could optimize it, but Ryven itself is kind of a general purpose editor. So it just provides you with the implementation of this idea of flow-based visual scripting. And you can pretty much build anything you want using it, as long as Ryven has the features that you need.
I'm wondering if there are any particular projects that maybe you have implemented in sort of the quote-unquote standard approach of just having text in a buffer and saving it and then just executing it using whatever the build tool is for the programming language, whether it's just invoking it with Python or building the C++ application or what have you, and then having revisited that with Ryven to rebuild it. And I'm curious if that's the case, how that made you think differently about how to approach the problem or how to structure the various components of the logical flow.
So I think one very important thing to mention is that, at least for Ryven, the idea is not at all to provide a full alternative to conventional coding, to textual coding. It's not at all the idea to replace textual coding in some way. It's just a different approach that requires a little bit different kind of thinking for different applications. So what you would not want to do, I mean, you could do it, but I think this quickly gets pretty messy, is taking a script that you have written in source code and basically creating nodes for all the atomic operations that you're doing, and then create this same thing using the flow structure. I did this myself just to try it out with like the basic examples like sorting algorithms, stuff like that. But it very quickly gets very messy. And I don't think this is where the strength of this idea is. It's more like the other way around, I think, because one good example, which also showed me how powerful this idea can be, is I was trying to build a small game in Unreal Engine 4 a few years ago. And I was using these blueprints to create the game mechanics and also to compute the level. I was procedurally generating a random maze, and you were just running through this maze, and there were like objects following you and stuff like that. And I had to write a script to procedurally generate that maze. And I couldn't really find an algorithm online that fitted my needs, so I just wrote this thing myself in a huge script. And not only I realized after actually was working that I could have never done that in pure source code back then. This was pretty huge. But what was much more interesting to me is that usually when I just coded something using text, I don't think I could have written something like that. And usually when I did write something, it was much harder to get into that code again when I revisited it afterwards. I could not just like look at it and know what this code was doing, how this worked. I had to read it again. Like I had to reread most part of the code to get a sense for what a program is actually doing. This was kind of new to me. And this is also kind of what inspired me to dig a little deeper into that and try to optimize that. Because I felt like there was a lot of brain power basically that was unused if you're using a paradigm or a representation of your information for anything that is not always the most efficient way to go.
And in terms of the way that the program is structured and displayed and the editing experience being a means of maintaining context and making it easier to jump into a piece of code, I'm also put in mind of things like literate programming, which is enabled by things like Jupyter Notebooks and the NBDev project, or in the Emacs ecosystem using org mode with embedded code. And I'm curious if you've ever experimented with some of the literate programming concepts and any parallels that you might draw between that and this flow-based paradigm.
So I don't really have experience with those systems. I know they exist and they are popular. Like, these Jupyter Notebooks are really cool tools for playing around, but also for doing scientific work, right? So I don't know much about the software behind it, but I was thinking about combining these systems with Ryven. So I've had a few conversations with people from scientific areas who are using, for example, Jupyter Notebooks for data science and stuff. I haven't really tried it, and it's not something easy to do, but integrating these kinds of systems like Jupyter Notebooks into an environment like Ryven, I think could be the best thing, because you can basically combine two very different but very intuitive approaches of structuring your program or structuring your computation and your data processing. And I'm not sure how I would go about combining these, but I feel like there are different ways. I made a few concepts, and it feels like this could be something that I'm definitely going to take a closer look at in the future to combine these systems.
Digging a bit more into Ryven now, can you give a bit of an overview about how it's implemented and some of the ways that it has evolved or shifted, or the goals of the project have changed since you first began working on it?
The development was pretty wild, because at any point in time, Ryven was always like a prototype of something. So in the beginning, I had implemented a few very different visual scripting editors in the past over the last few years. And Ryven kind of is like the result of that, because after those, and with the last one, with the biggest one, I took part in the youth science competition in Germany, and this was a very great experience. And after that, I sat down, and for a few months, I just made concepts, and I came up with the idea for Ryven, and I thought this could have a lot of potential to combine it with Python in this way. But of course, like, the software has evolved drastically always. It's not that the concept has changed, but it's rather that the concept has become more and more clear to me, I guess. Because in the beginning, I wasn't really sure how exactly or at which level of abstraction this would be very useful. And I also thought that this would be primarily directed towards execution flows and stuff like that, while now I would actually say this is much more powerful for data flow programming. It has evolved in a bunch of ways. I have basically always tried to add more features to make it more intuitive in use. So at the beginning, it was kind of a sketchy process to create new nodes and execute them. And meanwhile, I think it's quite intuitive. So there is Ryven, and besides Ryven, there is the Ryven Node Manager, which is a second application that you use to create these nodes now. And it basically provides a small code editor and a bit of intuitive graphical user interface to create these nodes, define initial inputs, define initial outputs, give a description, a title, a color, stuff like that. These things I introduced over time because I felt like this was really an important thing to have. And like, I always went a little further month by month. So one of the first big things that I implemented is Ryven Console, which is basically an application that runs a backend version of Ryven without any graphical user interface. So once you have made a flow and you have saved it, you can then run it in Ryven Console without any graphic user interface and without any Qt dependencies. So you can, for example, run this on a server to, do some database processing overnight or something like that. This was really cool. After that, I introduced things like a console, a built-in interpreter. So inside Ryven, you can click on a node and on such a block called node, and you can add a reference to this node to the console. You just have a reference to the object inside the scope of the interpreter, and you have access, therefore, to all the internal data through this console. And this is really intuitive because you have full access to the whole API. You can add and delete inputs and outputs and do all that kind of stuff. And probably the biggest thing that I added for Ryven then was code generation, which is kind of a very commonly discussed thing, because when you think of a flow-based visual scripting editor, you're asking yourself, does it export code? So when I have a flow, can I export all my work into one single Python file to run it anywhere, to embed it in my software or somewhere? And while I was kind of reluctant to add this for a long time, because this is not really the idea of Ryven, because Ryven itself is not really a software for developing software, but rather an exploration software. So when you have a node package for, say, OpenCV, right? So you have a node package with a lot of nodes that just apply effects on OpenCV, effects on images, then you can place these nodes and play around with them, and then you can discover some new effects or something. I think this is something that it's really useful for. And therefore, it's not really the goal to export a code that would be much more inefficient than what you could write as a human. But nonetheless, it would be something very nice to have, right? So I think it was like 2 months ago or something. It's not yet in the official release, actually. It's just in the master branch on GitHub, is a prototype implementation of a code generation. So basically, it runs a short semantic analysis on all the nodes. And then it shows you a list of the dependencies that the nodes use to specify which sources should be included in the target file and which shouldn't. And then you can just click generate code, and it generates the whole source code out of this, which basically means it creates a file where all the class definitions of the nodes used are included, as well as a very minimal implementation of the backend to execute the flow, and a function or a main routine that just very explicitly creates all the objects and creates the connections and builds up the flow. And then you can add functions, and you can also modify the flow. I can't really say where this is going in the future, but I'm pretty stoked currently about where this is right now, because 5 months ago or something, I wasn't imagining to have these kinds of features included in 5 months. The fundamental concept never changed drastically. I just added features that I think are really useful.
As you work on building Ryven, how much of it are you able to actually use on itself, where you can dog food the Ryven development with Ryven as the editing environment?
This is actually a question that I get many times, because it's a funny thought. No, I'm not. Because again, Ryven is not at all like something that you would use to build conventional software. But it's a funny idea, and we have a few friends and me, we had ideas of creating kind of splash screens while the flow is loading, while this flow that you see in the splash screen is basically the code that is executed creating the flow and stuff like that. So yeah, maybe in the future, but so far Ryven is just implemented by hand in text.
And so for people who are using Ryven to build a script or build a project with it, I'm curious if you can just talk through the overall process of getting started and the workflow of designing the program and creating the various nodes within the execution structure, and just some of the ways that they should be thinking about how to use Ryven to fulfill their goals.
There's not really a very clear or solid path that you go when developing nodes for Ryven. Usually I create a basic skeleton of the nodes that I want to use in the node manager, and I save it as a node package, and then I start Ryven and I import this node package, and then I place these nodes and play around with them and repeatedly just add functionality to the nodes. So I mentioned the interpreter reference feature, where you have access to internal data and also to the API, so you can dynamically just add inputs and outputs and stuff like that. And there's also the implementation is kind of sketchy, but it works surprisingly well. There's a source code editing feature. So you can, of one individual component of one node that is instantiated and placed in the flow, you can reprogram method implementations of this node. And this way, it's pretty efficient to develop new nodes and try out different things. And then when I'm done, when I know how I want to implement this node, I just take the code from Ryven and put it inside the node manager, inside the node package. So that's kind of the overall process to write new nodes. When creating the script, I don't know, it probably really comes down to what you're trying to do. I usually just use this for playing around and exploration, and this just involves a lot of playful trying out things, and there's not really a very solid procedure that I follow to solve some kind of problem. This is more like a tool for exploration.
Another interesting aspect of working in this kind of environment is being able to integrate with the broader Python ecosystem for things like code quality or implementing some sort of testing, or how you handle things like version control. And I'm wondering if you have dealt with any of that, or if it's still just in a prototype stage, so you haven't dug too much into the sort of code quality and correctness aspects of how to manage a more long-running workflow for somebody building with Ryven.
The latter. So I haven't really spent a lot of time trying to implement things like version control, because all those are tools that you apply on conventional source code to keep your code clean. But in Ryven, you're not coding using source code, or at least like you have this kind of source code layer which is the code implementation of your nodes. But you use this kind of in assumption that this code is correct and works. And Ryven just extends this layer by introducing the graphical structures, and then you can play around with that. And it just adds something to this code layer, but you're not really in strong interaction with the code anymore. So I'm not focusing yet on these tools to provide like version control or something, which are more directed towards, as I said, like code quality and stuff. As you said, it's still in a very early prototype stage, so I'll see what the future brings.
Another question, which is a little bit of an outgrowth of the previous one, is how you manage things like collaboration on a Ryven project, like being able to define a set of nodes and then share that with somebody else to be able to either add to that library of nodes and append to the existing flow structure, or just being able to reuse some of the nodes that you've defined and, build up a library for, a team or a individual who wants to be able to reuse Ryven for different problems in sort of adjacent domains.
So far, I haven't set up a particular system for this. I would like to in the future, if this receives enough usage and a lot of users would benefit from that. So far, it's basically just through the GitHub community. So basically, you're just like forking the project on GitHub or something, and you're adding your nodes, and everyone can see them. And if those nodes are compatible with normal Ryven projects, then I usually try to integrate those into the main repository to add them as node packages. This is what happened, for example, with the OpenCV nodes, this OpenCV node package to apply OpenCV effects on images. I just created like 2 or 3 very basic nodes for this, but then someone from, I don't know, I think like Istanbul or something, created like 20, 30 more nodes, and I saw that on GitHub, so I just quickly integrated them into the main repository. So far, there's not really a system set up, but I would like to create like a cloud-based built-in system in the future where you can like upload your nodes and also your flows to the cloud, and everyone can just download them. This would be really nice, and that's definitely something I'll think about in the future.
In terms of the ways that you're using it or projects that you've seen other people build with Ryven, what are some of the most interesting or innovative or unexpected ways that you've seen it used?
I think it's used in very different ways. I'm not sure I'm seeing everything on GitHub, but some of the ways that were pretty unexpected was, for example, last year someone contacted me. It was a data scientist from the Netherlands. Someone contacted me and wrote me an email that he's using this for like database processing for big data. And he requested a way to run a flow without a graphic user interface on the server after he sufficiently tested the flow and know it works, so that he can just do all the processing overnight on the server. So this is basically how Ryven console was born. And this is something that I didn't see coming at all. There's a lot going on in the machine learning fields, because apparently a lot of people see a lot of potential for this regarding machine learning. So, for example, someone is currently creating a node package for the most common scikit-learn methods. So scikit-learn is this popular library for machine learning in Python, and for data science purposes, he forked this project and is creating a bunch of scikit-learn nodes for this. Stuff like that I didn't expect in the beginning, because in the beginning I was still pretty focused on these popular editors like Node-RED and the editors from Unreal Engine, which are basically very different kinds of use cases. So it was quite interesting to see that people are actually using this for things that I didn't consider at all in the beginning. And I'm pretty sure there's a lot more to come. Like, someone is currently integrating this into Unreal Engine, actually, to have a more Unreal Engine-like way of automizing a workflow. I think they want to use it as an automation tool and stuff like that. This is pretty cool and wasn't intended in the beginning during the design of this project.
That's pretty cool that Unreal Engine was some of your original inspiration for building this project, and now some of your ideas are getting factored back into that tool.
Yes, absolutely. This is this is very exciting, because I didn't even try this myself, because I assumed that this would require a lot of additional configuration. But apparently this is possible. There are two popular projects implementing Python into the Unreal Engine. There's Unreal Python and Unreal Engine Python. The one is from Epic Games and the other one is third party. And both are very useful for like workflow automation. So if you're making a game in a small team, you have a group of developers and designers, then you want to have some workflow of getting your assets that you created in some modeling software like Autodesk, Maya, Blender into your software, and you maybe want to do some computations on it, on your textures or something. For this kind of workflow automation, Python is really useful. And I can see that this would be even much more intuitive using something that has this kind of flow-based structure. So I'm very happy to see that shifting towards Unreal Engine and seeing it getting used there, because as I said, I didn't expect this to happen. Vocabularies.
In your experience of building the Ryven project and using it for creating some of your own projects out of it, what are some of the most interesting or unexpected or challenging lessons that you've learned in that process?
Mostly technical details. This obviously is the biggest software project that I did so far, so it's just a lot of insight into how you should structure a project, and there's a lot of trial and error involved. Very technical details, usually how you should distribute or how you should decentralize internal parts of your software. Currently, I'm really getting into the threading part, because I will talk about that later probably, but I'm adding like threading features for Ryven software. So the lessons I learned is mostly regard the technical details. But what I wasn't used to up to this point until a few weeks ago, where this kind of started to take off a little bit on GitHub, was really getting in touch with the community. So there were a few things happening, like there were one or two short articles about me and the project in a Chinese Techno journal, which caused a lot of Chinese people to visit the GitHub repository, which caused the GitHub repository to move up to the GitHub trending page for 1 or 2 days, which then caused also a lot of Western GitHub users to visit the repository. And this way, I just got into touch with a lot more people who were really interested in the project. And that was just in general like a great experience to see so many people interested in the project I'm building and eager to join the discussion on flow-based visual scripting and stuff like that. So this was kind of just a great experience.
As you continue to work on Ryven and use it for your own purposes and work with other people who are using it for different projects, what are some of the things that you have planned for the future of it in the near to medium term?
A lot. There's a lot happening right now. So about 2 months ago, I started to split the Ryven project into two projects because I always had this idea in my mind that the ultimate goal for me would be to create something like a small framework that you could use to easily optimize such editors. What I'm developing right now based on the Ryven project, so based on the Ryven software, I'm right now developing a small framework, a Qt-based framework for Python that just makes it very easy to create these editors and to optimize them. So say you have a bunch of node packages that work well in Ryven, you can then create your own editor using Ryven. This thing will be called Ryven Core. You can use Ryven Core to build your own editor and really optimize it for your specific domain. That's very exciting because I was skeptical if this would work, if this would be intuitive in use. But so far, it looks pretty good. And I'm actually currently adding a bunch of features that are not part of Ryven. Ryven, in the end, will be built on top of Ryven Core. But Ryven Core will be very free in the way you use it, not very restricting in application. So, for example, one thing that I'm developing right now that I'm especially enthusiastic about is a threading system. So I don't know much about threading at all, but I really wanted to add this. So I'm just really playing around with this currently a lot. Actually, already when I started planning the project, I knew that if I would want to do this in a very professional way, then I would have to add this at some point. And it's basically the idea to keep the abstract logic of the flow in a separate thread. So all your graphical user interface runs in the main thread, and then you have a separate thread where all the abstract logic is executed. At first may seem like just some minor performance improvement. This is actually crucial for enabling real-time data processing applications. Whenever you have some kind of static flow of information into your software, say you have a microphone that is recording, or you have a camera, or any data that's coming in, and you do some real-time data processing on this data, then you want to have this kind of threaded separation of responsibilities. And is a hard thing to implement because Ryven Core is not only going to provide the management for the abstract logic, but it's also going to provide the graphical user interface for the flows and everything that's contained, because this is effectively the biggest part of the code. And therefore, I have to make sure that the whole communication between the internal abstract objects and the widgets is implemented somehow thread safe. And I need to add some kind of intuitive API so that you can easily update your widgets once your data computation has updated. So Ryven Core will just be like a simple framework to use to create these editors, and it just provides you with a lot of stuff that can be hard to implement. Things like save and load, at first a prototype for this code generation I was talking about. Things like that you can like make pictures of the flows, which is also already part of Ryven. So when you have like a flow, you can make you can render a high resolution picture of the flow to use it in a presentation, for example, things like that. And all this will just be done by Ryven Core, and it will be very easy to create these optimized editors. And I feel like there's a lot of potential for this. I already have a bunch of ideas for optimized editors, and I actually cannot wait to to start working on those. So the first release of all this is going to lead to the release of Ryven 3, and the first release of all this is probably going to take place somewhere during the next 3 months, I would say. But yeah, there is a lot to come.
Well, for anybody who wants to get in touch with you or follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And with that, I'll move us into the picks. And this week, I'm going to choose the project PyInfra. I've started using it recently for prototyping deployment of a new system that I'm working on at work. I've been pretty happy with it so far, just being able to use pure Python for being able to build up the logic of getting the server set up and configured, as opposed to all of the YAML that I've been dealing with for years. So definitely worth checking out if you're working on deployment or management of any systems. I actually had the author of that project on the podcast a while ago, so I'll add a link to that episode as well. And with that, I'll pass it to you, Leon. Do you have any picks this week?
Yeah, so I would actually like to promote a book that I read a few months ago by Lawrence Krauss, who's a theoretical physicist. It's called A Universe from Nothing, and it basically deals with the idea, how can there be a big bang or something when there's nothing before? And therefore, this is more like it contains a bunch of philosophical ideas, but it's still very scientific. It's quite phenomenological in a way. In my eyes, it contains a lot of very important scientific thinking. So if you're somehow into like theoretical physics or something like that, I can absolutely just recommend this book. It really blew me away because this kind of methodical scientific thinking was very impressive and kind of unique. Yeah, I really enjoyed it. So if you're like somehow into that, these kinds of books, I can absolutely recommend that.
Well, thank you very much for taking the time today to join me and share the work that you've been doing on Ryven. It's definitely a very interesting project and a different way of thinking about programming. So I'm excited to see some of the directions that you're able to take it in. So I appreciate all the time and energy you've put into that, and I hope you have a good rest of your day.
Thanks for having me. It was a pleasure.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.